section 3.1, we're going to be talking about what's called paralines and transversals. But before we do that, we need to do a little bit of review and just kind of hit some topics you may or may not remember from the past. And the first one is, of course, the term of an angle. Not really going to define this as much as just show you what an angle looks like. It's basically just like this. It's when what we call two line segments or two rays come together at what we call a vertex, and we end up getting this shape. This is what an angle is. And what we typically do is have a protractor, and we can measure out the degrees between these two line segments. So nothing really over complicated on that. That shouldn't be I'm not going to go into much detail on that because it should be review. But remember, where the angle meets is the vertex. Now, how do we name this angle? Is we can name it about three different possible ways. We can call it angle ABC, representing the points of that angle. Or we can do it angle CBA. Both of these are correct. And then we could just call it angle B, and that's also correct. And notice about the one thing that's constant in all three of these names is the letter B. And the letter B is there in all three of these names because it's the vertex. It's the middle of the angle. So just keep that in mind. So a couple other things that should be a review is the concept of adjacent angle. Adjacent angles are when two angles are sharing a side. That's it. So this angle right here and this angle here, they are adjacent because they share this same side. Vertical angles are opposite angles formed when two lines intersect. So I have basically, it's like an X. So I have two lines that intersect and they form a series of angles. And the opposite angles, notice this angle and this angle, which are opposite one another, they're the same angle. So this is very important to understand that vertical angles, their opposites are the same. So this and this are the same, and this are the same. All right, the last two big terms that should be a review for you are what we call complementary and supplementary angles. Complementary angles are when two angles add up to 90 degrees. So here I have a 35-degree angle and a 55-degree angle, and they are adjacent to one another because they share the same side here. And if we add those two numbers up, which we can do, 55, if my math was correct, plus 35 is 90 degrees. All right, same thing with supplementary angles, but they add up not to 90, but to 180. So these two add up to 180. And these are adjacent angles. This is 63, that's 117, add them together, 180. Now, this is probably the one thing that confuses a lot of people are the terms complementary and supplementary. Whether this helps you or not, I don't know. This is the way I've always remembered it. The letter C stands for complementary. And if we were to do this alphabetically, C comes before the letter S. So C is before S as 90 is before 180. This is the one I always remembered it. Since C came first alphabet, that means that it's the 90. And since S comes second in the alphabet, it means that it's the 180. This is the reason why, or how I've always remembered complementary versus supplementary. It might help you out because it helped me out. All right, so those are some basic definitions that should be familiar with and just a little refresher. Now let's get into some of the newer concepts. All right, transversal. It's a line that passes through two or more parallel lines. So I have a parallel line here, and I am literally going to make what's called a transversal. Bam, I just did a transversal. It crossed two parallel lines. And in doing so, it created what's called corresponding angles. These angles right here, I'm going to call this A, B, C, and D. And it creates corresponding angles. These angles right here correspond with these, A prime, B prime, C prime, and D prime. These are all corresponding angles. Well, this also leads us to a couple of things that we can say. If we know the measurement of A, we know the measurement of A prime. These two things are the exact same measurement. as is B and B prime, C and C prime, D and D prime. And I'll give you what's what's happening there in just a moment. But let's go on to some other terminology. So I have a transversal is crossing my parallel line, and it creates a couple of things. One, it creates interior angles, which makes sense. It's the ones that are inside the parallel line. So it's literally just the same thing as up top. But the ones that are on the inside of the parallel lines are what we call interior angles. The ones that are on the outside of the parallel lines are what we call exterior angles. All right? And then we have a couple of little rules that go along with this. So it says alternate interior angles. So it's saying this is our little rule. This angle C, its measurement is equal to angle B prime. These two share the exact same number. If this number was 60, so is this. And then it goes farther and says that angle D is the same thing as angle A prime, meaning that these two share the same measurement. Then it gives a last thing, alternate exterior angles. And it's the same concept, but this time A is equal to D prime and B is equal to C prime. Now, there's a lot of terminology right here in front of your paper, so let me just go ahead and cut to the chase and show you what all of this jibber jabber really means. And it's going to make your life really, really simple. So, let's go ahead and use this one. Let's use this. It's saying use the figure to find the measure of the numbered angles. Well, the one thing that we know right now is I have two parallel lines and it's been cut by a transversal. This measurement right here is 112. Well, if I were to do a little bit of math here, and I know one thing, this is a straight line. This angle that's right here is supplementary to this angle right here. That means that this plus whatever this is right here, I don't know what it is, should add up to 180. So let's find out what that missing angle is. 180 minus 112. I found out that this angle here, the one that is literally right beside it, is 68. The hard part of this entire thing is now complete. Because watch what happens. Based upon all those rules and jibber jabber I just gave you and everything like that, I can simply say this. If I know this to be 112, I know this is 112 because they're vertical angles. If this is 68, then this is 68 because they're vertical angles. And because this transversal makes corresponding angles, this entire thing can be copied over here. So that means that this angle right here is 112, this is 68, this is 68, and this is 112. Another way you can look at it is look how it flip-flops. 112, 68, 112, 68, 68, 112, 68, 112. Basically, what I'm trying to get you to understand is if you know one, you know them all by just plugging them all in. So we just found out that angle 1 is 112 degrees and angle 2 is 68 degrees. Let's do another one. So it tells me what this is. It's telling me that 34, but it's asking for 1, 2, 3, 4, 5, 6, and 7. I need to know all those angle measurements. Now that seems like a lot, but check this out. I know for a fact that this is 34. And this 3 right here is supplementary to that angle. So I can simply say 180 minus 34, and I get 146. So this becomes 146. Now that I know what the two angles are, I can literally flip-flop. This one here is 146 because they are opposite and they're adjacent, not adjacent, but vertical angles. These two are vertical angles, so those get flip-flopped. And now I just repeat my pattern. This would be 146, this is 34, this is 146, this is 34. I've repeated. And now I can go down the line. 146, 34, 146, 34. Repeat. 146, 34, 146, 34. Now that I know everything, I can just plug it in. Angle 1 is 146 degrees. Angle 2 is 34 degrees. Angle 3 is 146 degrees. Angle 4 is 34 degrees. Angle 5, 146 degrees. Angle 6, 34 degrees. Angle 7, 146 degrees. So it's literally repeating the pattern. Yes, there was a lot of words at the beginning of the video, but in all truth and honesty, if you see the pattern, you're pretty much done. And that's really this geometry little section up pretty much in a nutshell. So why don't you try 3, 4, and 5 on your own just to see how you do. What you should have got for number 3 was 30 degrees, for number 4, 138, and for number 5 is 28. And if you don't know exactly how I got this, basically just simply this. If you know angle 1 is 150, you know angle 1 is 150, you know angle 2 to be 30 automatically. And now you just flip-flop your numbers all the way down. Once you've done that, erase it, and try your next one. We know angle 3 is 42. And if this is 42, we can work this one out right here to be 138. Flip-flop your numbers. And then you could do the same thing with number 5. All right? So it's pretty straightforward. I don't think that one's too confusing, but if it is, you know how to find me. All right. Number 6. You paint a border around the top of the walls in your room. What angle does X need to be to repeat the pattern? So right now, it kind of looks a little confusing because where are my parallel lines? I've got 2 sets here and I've got 2 sets here. So really, it doesn't really matter on this particular piece. So let's just extend some things out, okay? And then you can probably make this a little bit simpler to see. So if you know that this is 154, you should be able to figure out this one. And if you know what this one is, you can figure out the rest of your pattern. And I'm going to leave that one to you. All right, this is your challenge problem. So I've given you a little hint and kind of stretching the lines out. Treat it just like you did before. And that's it for this video. And I will see you in the next one. Bye-bye.